Today's lesson will be on scale factor, and it will cover various types of problems that use scale factor. We'll start with all of the examples that have been pre-done for you, and then you're going to try the you try problems. So please add these 3 pages to the notebook. This one, page 28, is from the lesson the first lesson we did on scale factor, which was working with scale factors, and you were enlarging different shapes. That one we just need to add to the notebook. And then 29 and 30 is what this video will cover. So on page 28, please add in this worksheet that we did in our previous lesson. I'd recommend just putting a little piece of tape and folding it into your notebook on page 28. So we're going to start off with page 29 that has the grasshoppers picture on it. So if we have an original scale of a 1:1, this is the image enlarged by a scale of 2 and doubled, and this is a scale of 1/2 essentially, because it's the original is 1 and 1:2 versus a 2:1. So we're going to look at example 1 on the front of this first. So example 1, it gives us a scale factor of G to H is 1.5 to 1. So that means that from H to G, this image has increased by 1.5 times. So what I did is I set up my ratio of shape G to shape H, and G is 1.5 and H is 1. So therefore, X is on shape G. So I lined up X with 1.5, and then X corresponds to 5 feet on shape H. So H would be the 5. And then looking at the relationship, to go from 1 to 5, it's been multiplied by 5. So 1.5 times 5 would be our X value. And that's why over here I wrote 1.5 times 5 is 7.5 feet. Now here, to find our Y value, I did G over H again, which is 1.5 to 1. This time the Y is on the H shape, so that goes in the denominator, and then Y corresponds to 9 feet on the G shape. And then what I did to find this value here is I did 9 divided by 1.5 to figure out what times 1.5 is 9. So 1.5 times 6 is 9. So down here, 1 times 6 is our Y value. So make sure to highlight key information, maybe highlighting the X on shape G in a color so that all of these are the same color, and then highlighting like the 5 to match all the H values so your notes make sense. One last thing to point out, if you want to look at the relationship from 1 to 1.5, that's times 1.5 because our scale factor is 1.5. And same thing over here, times 1.5. So to go from here to here, it would be times 1.5. So to solve it, you would actually do 9 divided by 1.5 to get 6. Okay, on the inside left of the notes, we have example 2. So the setup is actual compared to the map. Well, the problem tells us the actual is 450 miles and the map is 1 inch. So it's a 1 to 450 ratio here. To go from 1 to 450, we're doing times 450. That's our scale factor. And then the actual distance would be the 2, oops, this needs to get shifted over, I'm now realizing, the 2.5 inches, 2.5 times 450, or 1 times 2.5 to go here, 450 times 2.5. Regardless, you're going to get your answer of 1,125 miles. And there's the pre-written example. So you should be highlighting your original value, which would be the map, and then the new value or the actual value, which is 450. So color coding things. Okay, we're on to the bottom left of the notes, example 3. We have an original image here that's been reduced to create a new image, and it's asking for what the scale factor is. So remember, we have to do 15 times something equals 3. So it's not 5. The scale factor is not 5. That's a common mistake. So in order to find it, we are going to do our new divided by the original. Think of our Y over X. So we have our new value of 3 divided by 15. 3 divided by 3 gives us 1. 15 divided by 3 gives us 5. So our scale factor is 1/5. And as a decimal, that would be 0.2. So our scale factor is 1/5. So multiplying by 1/5 is the same thing as dividing by 5. So 25 times 1/5 is 5, and 20 times 1/5 is 4. Now we're on to example 4, top right of the notes. So this one's pre-done, and where the values came from is 5 inches is equal to 6 feet in this scale. So therefore, to figure out 5 times what is 6 feet, like what our scale is, we're going to do 6 divided by 5, which is 1.2. So our scale, therefore, is 1.2 feet for every 1 inch. So it's a multiple of 1.2. So the equation would be y equals our scale, which is 1.2, times x. To actually use this to solve for the actual width, the width is 18. So 1.2 times 18 is 21.6 feet. And then the actual length would be 1.2 times 14, which is 16.8 feet. So please make sure to highlight so you know where these values came from. You could draw an arrow from the length over to this work to make things clear. Okay, last example that's been pre-done for you. We have a scale drawing of the backyard tennis court. The scale is 1 centimeter to 2 meters, and the final answer needs to be the actual area of the tennis court. So we're looking at finding the actual area. So it's good to draw a sketch. That's why I did that on the paper. Our scale is 1 to 2, so it's increasing by a multiple of 2. And therefore, we're going to find the actual lengths. So this length started as 10. We multiply by 2 to get 20 meters. The drawing length is 7.5 centimeters. Times 2, we get 15 meters. And remember, we're finding the area. The area of a rectangle is length times width. So 20 times 15 is 300 meters squared. We use square meters for area because that's how you cover a surface. So here is the pre-done notes. Please highlight what would help these notes make more sense. And now you should try the U-tries. So what I would do is I'd pause the video and I'd try all the U-tries, and then I'd watch the video to see how I did. So on U-try number 1, we have a scale of K to L is 1/2. So K to L is 1/2 to 1. And then we look at each of these shapes. K, this length here is 12, and L has the X. So that's why I line things up. And then we're trying to figure out, how does 1/2 become 12? Well, half of 24 is 12. So 1/2 times 24 would be 12. 1 times 24 would be 24. So remember, going from here to here, it's a half. So going from here to here, it's going to be double. Therefore, X is 24 yards. And then to solve for Y, we have the same scale. We have Y over 4. So we're trying to think about, how does the 4 become a 1? And if we think of what's half of 4, okay, here, that would be a 2. Or you could think of it as divide by 4 or times 4. This way actually makes more sense. 1 times 4, 1/2 times 4 is 2. Now on your paper, I know these grid lines are very light, but in order to do this problem, you are going to have to see the grid lines, so hopefully you can. So it says the picture to the right is a scale drawing of a truck. Based on the information, what is the actual length of the truck? So we are given our scale here. 1 inch is equal to 2.1 feet. So 1 inch is equal to 2.1 feet. Now, therefore, the scale factor is increasing by a multiple of 2.1. So our scale factor is 2.1. And then we need to find the actual length of the truck. So here it says the grid lines are spaced 1 inch apart. So we need to count the squares to find the length of the truck. So the truck goes from here to here. And if you count each of these squares, you're going to get 13 squares, which means that the truck drawing is 13 inches long. Now to find The actual, we're going to take 13 inches and multiply by 2.1, or you could take 2.1 and multiply by 13, because going from here to here, it's times 13. Regardless of which method, because they're going to be the same multiplication, you're going to get 27.3, and it is feet. 27.3 feet. You try number 3. So we have an original that's getting enlarged. So the new is 56 and the original is 16. If we divide by 16, the scale factor is 3.5. Therefore, we take 2, multiply by 3.5 to get 7 yards. And we take 8 and we multiply by 3.5 to get 28 yards. Example 4, we have a scale that is going from 1 inch is equal to 11.6 miles. So therefore, 4.5 times 11.6 will be 52.2 miles. Now, the equation, you're just going to use your scale factor as our constant of proportionality. So we have scale factor of 11.6. Therefore, the equation is y equals 11.6x. If the map shows a house is 12 inches from the college, what is the actual distance from the college, or from the house to the college? So therefore, you take your scale factor, 11.6, multiply by 12, and you'll get 139.2 miles. Last, you try number 5. So it wants us to find the square feet of flooring needed to cover the entire dining room. So we look at the dining room, and it's telling us that each square is 1 inch. So down here, the grid lines are spaced 1 inch apart. So therefore, we have 2 squares, 2 inches, by 3 squares, 3 inches. So that's the picture. But we need to find the actual square feet for the entire dining room floor. So the actual is going to be equal to each of these values times 7, because our scale down here is 1 inch equals 7 feet. So 2 times 7 is 14 feet, and 3 times 7 is 21 feet. And it wants the square feet needed to cover the entire dining room, so we have to find the area. Area is equal to length times width. 14 times 21 is 294 feet squared, and that is it for this lesson.